two particles could be moving in such a way that they're moving at an angle and they collide and then they rebound and they start traveling in different directions. So these are the two velocities of the two particles before collision, and these are the two velocities of the two particles after collision. At the point of collision, velocities which are perpendicular to the axis of particles, the individual velocities would remain same. So the initial vertical velocity of m1 is same as final vertical velocity of m1. Initial vertical velocity of m2 is same as final vertical velocity. So you have to resolve them for oblique collision, and you have to recognize that their vertical velocity will remain unchanged. That's because the only force that acts is a contact force, and that acts only right and left. Since there's no force, and by the way, when you're looking at these particles, guys, please remember it's more like a pool table, snooker table, and you're looking at it from top. So the only force that acted on them is the force of collision, impact, and that's only horizontal, and that's why their individual vertical velocities are not affected. So vertical velocity of m1 remains same, and vertical velocity of m2 before and after collision remains same. But since there is a horizontal force, so the horizontal individual momentum might not be conserved, but the total horizontal momentum would be conserved. That means m1 u1x minus m2 u2x equals minus m1 v1x plus m2 v2x. For horizontal momenta, you have to apply the conservation of momentum. And for, if you know that this oblique collision is elastic, then you can also apply that relative velocity of approach is equal and opposite to the relative velocity of separation. But only for horizontal components of velocity, and vertical components would remain the same. And this is something that has come more often in exam, guys. And one particle is resting and another particle comes, and it's not a head-on collision, so it just collides at a particular angle and they move off in opposite directions. So the vertical momentum would be conserved and horizontal momentum would be conserved. So what is the initial horizontal momentum? m1u. What is the final horizontal momentum? m1 v1x plus m2 v2x. And hence I could say m1u is equal to m1 v1x plus m2 v2x. And also the vertical momentum would be conserved. So if you see, this particle is moving horizontally and this particle is resting. So initial vertical momentum before collision is 0. And final vertical momentum is m1 v1y minus m2 v2y. So 0 equals m1 v1y minus m2 v2y. So that's how I get the other equation. That's also conservation of momentum. So vertical momentum would be separately conserved and horizontal momentum would be separately conserved. So you can also represent that on the vector diagram. The vector sum of final momentum should be equal to the total initial momentum. Okay, so these two examples that I would want you to understand is that let's say there's a truck moving horizontally and something lands falling vertically on top of the truck. So that will cause the truck to slow down. That's because when the parcel fell onto the truck, it never had any horizontal momentum. But when it landed on the truck, it started moving horizontally with the truck. So that means it gained horizontal momentum from the truck. And hence the horizontal momentum of the truck would decrease and the truck is going to slow down. When parcel was there on the truck, it already had a horizontal momentum, and I just pick it up. So when I pick it up vertically, it came out with its own horizontal momentum and never had any exchange with the exchange of momentum with the truck. So if it lands, the truck is going to slow down, but if I just lift it vertically up, then the speed of the truck would remain unchanged. The particle is moving with horizontal velocity, and the parcel would also be moving with that horizontal velocity. So if I just release the parcel from the helicopter, So that would also not cause any change in momentum of the helicopter, because parcel will move out with its own horizontal momentum and helicopter will continue to move with its own horizontal momentum.